Hey guys, welcome back. Imagine in your company you have a 50-node Hadoop cluster. The cluster is usually busy in the morning, and you have several important MapReduce jobs running in the cluster at that time. Now imagine a name node failure one morning. When a name node goes down, the HDFS metadata, that is the information about the files, folders, block locations, etc. for the cluster, becomes unavailable. This means you cannot read and write anything to HDFS. When you cannot write and read anything to and from HDFS, you have a serious problem resulting in job failures. You cannot execute any MapReduce jobs, pig or hive scripts in your cluster when the name node is unavailable. And also the job currently in execution will also fail. This, of course, will result in complete chaos. Engineers will be woken up in the middle of the night to fix the problem, and if the problem is not fixed in reasonable time, you will have your business users escalating the issue up to your higher management. In short, this results in complete chaos and panic. I've been in this situation twice, and I can tell you it is not a fun situation. That is why Namenode as a process is a single point of failure in your Hadoop infrastructure. Failures in any software infrastructure is inevitable. Especially when an infrastructure involves a lot of servers, it adds another level of complexity, and failures are very common. In this lesson, we are going to look at recovery strategies that can be used to recover from name node failures. Whenever we discuss this topic in our training sessions, students will immediately ask, but what about secondary name node? Can we use that when the name node is down? Our answer would be it is not that straightforward as you think. Secondary name node is another node in your Hadoop cluster. The hardware configuration of the secondary name node is very similar to that of name node, and it has most of the information, if not all, that is stored in the name node. Which raises the question again, why can't we use the secondary name node when the name node is down, since it has almost all information that the name node has, and the hardware configuration is very similar to that of name node? To understand why, we need to first understand the purpose of secondary name node. As we know from the HDFS architecture lesson, the name node keeps the metadata of HDFS in memory. It also maintains a file named the FS image file, which is persisted in the hard disk. So in the event of hardware failure in the name node, FS image file can be copied over to another node and bring up a name node on the other node. So when a client like us requests a write operation to HDFS, the write operation is noted down in the metadata, which is stored in memory. This write operation will be quick because it is done in memory. But to keep the FS image file up to date, we need to write any new information to the FS image as well. This way, what we have in memory is always in sync with what is in the FS image file. Here comes the problem. In a busy cluster, when you have a lot of write operations going on, recording all the information on a huge file like FS image file on the disk becomes a bottleneck, and it will slow down the regular HDFS operations. So recording all the information to the FS image file on the name node is not advisable. So what is the solution? We can do this. How about keeping an intermediate edits file, and any write operations will be recorded in the edits file. And periodically, a background process will pick up the edits file and will merge the contents of the edits file with the FS image file. Once the contents are merged, the edits file would start fresh. This means that the edits file will always be smaller in size, making any writes to the edits file much faster. Sounds like a good solution, right? But there is a problem again. I'm nothing but bad news today, right? As we know, name node is already a busy node in the cluster. Merging edits and FS image is a resourceful operation. So it is not a good idea to ask the name node to do any more extra work than it is already doing. This is where the secondary node comes in. The secondary node does not service the clients, meaning when you request a read or write operation to HDFS, your request will go to the name node and not the secondary name node. The primary function of the secondary name node is to periodically merge the edits file with the FS image file, and this is how it does it. In a predefined interval, the secondary name node will ask the name node to roll over the edits file. At this point, the name node will create a new edits file, and all the new writes will go into that file, and nothing will be returned to the original edits file from this point. Now, secondary name node will copy the edits and the fs image file from the name node and start merging the copied edits file with the fs image file, and then return the newly merged fs image file to the name node. The name node will then overwrite its version of fsimage file with the fsimage file from the secondary name node. The name node will rename the edits.new file to edits file at this point. This way, edits file is kept small and the intense merging operation of the edits with the merged file is offloaded to the secondary name node. This operation performed by the secondary name node is called the checkpoint operation. At any given time, the secondary name node will have a copy of the fs image file that it copied from the name node. Now that we understand what is the purpose of the secondary name node, let's ask the question again. When a name node is down, can we use the secondary name node as the name node? Excellent question. What do you think? Even though, as a Hadoop developer, you will not be asked to recover a failed name node. It is more of a Hadoop administrator's responsibility, but it's always good to know and understand the name node recovery options. Let's talk about different name node failure scenarios. Let's say name node lost the power for split second. In that case, the name node will go down, but there is no hardware failure, so the name node can be started on the same node. During the restart, the name node goes into a safe mode. In the safe mode, the name node will not accept any read or write requests from the clients. Let's say the last checkpoint operation was performed by the secondary name node 20 minutes ago. The fs image file the name node has will not have the recent information from the edits file. That is, fs image will be missing the information that went into the edits file for 20 minutes. So the name node will copy all the information from the edits file and merge it with the fs image file itself, bringing the fs image file to current. Remember from the HDFS architecture lesson that the name node does not persist block locations in the disk. So the name node will ask all the data nodes to send the list of blocks that it is responsible for and wait for block locations from the data nodes. When it has sufficient block information for the files in the cluster, name node will come out of the safe mode and start servicing clients. Name node is also equipped to do this automatically without any manual intervention from the administrator. Now let's assume that the name node went down due to an unrecoverable hardware failure. If the hard disk in the name node is still accessible, we can copy the edits and the fs image files from the name node to the secondary name node, and we can make the secondary name node primary. This means changing the name node's address in all the configuration files across the nodes in the cluster. Or you can do a DNS switch pointing the name node address reference to the secondary node address and start the secondary name node as the name node. Now all the client requests will hit the new name node, which is our previous secondary name node. I said we need to copy the fs image and edits file from the name node's hard disk to the secondary node if the name node's hard disk is still accessible, correct? Why do we have to copy the edits and fs image file from the name node to the secondary name node? Because secondary name node will already have a copy of edits and fs image file from the last checkpoint operation, correct? Any guesses why? Let's say the secondary name node is configured to merge the edits and fs image file every 60 minutes. The last merge was performed by secondary name node at 1 p.m. So the fs image file that the secondary name node has is from 1 p.m. Now the time is 1:45 when the name node crashed. If we use the edits and fs image file in the secondary name node, which is from 1 p.m., we will be missing 45 minutes worth of data that was returned to the name node between 1 p.m. and 1:45 p.m. Hence, it's always best to copy the edits and the fs image file from name node to secondary name node if possible. But what if we have an unrecoverable hard disk failure at the name node? In that case, we have to live with the missing 45 minutes of data. Secondary name node will not take over the operation of name node automatically in case of the name node failure. Making secondary name node primary is not an automatic operation. It involves manual intervention from your Hadoop administrators, and sometimes it is a time-consuming operation. That is why secondary name node is not a drop-dead replacement for name node, as many new Hadoop learners would think. Also, many new learners think that the masters file in the configuration folder specifies the location of the name node, which is wrong. Masters file tells us the location of the secondary name node in your cluster. So if you open the masters file, you will see a host name in which we have the secondary name node running. In the next lesson, we will see how the concept of checkpointing is significantly improved in the newer versions of Hadoop. And also, to make the name node failure much more easier and faster, in newer versions of Hadoop, you can configure name node to run in high availability mode, which we'll see in detail in the next lesson. So to summarize, name node failures are fatal, and we need to have a good recovery strategy. The primary function of the secondary name node is to perform a checkpoint operation merging the edits with the fsimage file. Making a secondary name node a primary name node requires some manual intervention, and secondary name node cannot automatically take care of the functions of the name node in case of a name node failure. You're probably thinking the secondary name node should have been named differently just to avoid the misunderstanding. And you're right. We'll see more about that in the next lesson. See you in the next lesson.